Welcome, everyone. We're going to get started in about 2 minutes. Good afternoon and welcome everyone to the second session of the RBMA AI webinar series. Today we continue our deep dive into the impact of artificial intelligence on the field of radiology. Our focus shifts to exploring the innovative use of NLP and AI algorithms in optimizing patient appointment scheduling. Please feel free to participate by asking questions or sharing your thoughts in the chat throughout our time together from 3 to 4 p.m. Eastern Time. We'll answer these questions periodically as they pop up. This session is currently being recorded and will be available 24 hours after the session concludes. Now, let's go to the next slide and see our learning outcomes for today. After the webinar, participants are better able to understand how implementing NLP-based patient scheduling minimizes disruptions in your center's workflow, improves resource allocation, and prevents revenue loss. Understand how to leverage AI algorithms to decrease scheduling ambiguity, reduce human judgment, and decrease scheduling errors. And finally, learn how strategic scheduling and effective overbooking techniques can help optimize your schedule and improve appointment completion rate. Now let's go to the next slide and extend a warm welcome to our speakers today. We're thrilled to have you both on.
Thank you, Megan.
Thank you.
And my name is Edison Sepulveda, and I work in this wonderful world of AI and machine learning innovation for Paxiento.ai. And basically, I had an very early opportunity while I was working for a credit bureau to look at this world and understand how data can help change the world. That was back in 2011 when I first started working with some of these machine learning techniques, and looking forward to sharing with our audience how it is impacting already the world of radiology.
All right, everyone. And hello, my name is Rafael Peña Pelletier. I am an economist and data scientist with over 10 years field. Alongside Edison, I work at Paxiento.ai, also known as CCD Health. And with over 10 years of experience in core data science fields, currently working as a senior director of business intelligence and workforce management as well, driving business strategy through data-driven decision-making. So I'm glad to be here as well, and I hope we can get a lot of learnings from this session.
Wonderful. So let's begin. One of the things that we wanted to introduce first was our agenda for this session. And we're going to touch specifically on one subsection or subfield of AI that touches on natural language processing. Traditionally, what you've seen in radiology, specifically for clinical applications, it's the understanding using AI for interpreting images. What we're going to discuss today, as we're going to touch on the next slide, is mostly related to how the text that you get in your company is useful as well for some wonderful applications, mainly in patient access, but also can extend to some clinical application as well. And we thought of starting with a very clear and short definition of some of these concepts that you typically hear and are some of those buzzwords that you hear on the media nowadays. But many people either don't know what they are or just are misusing some of these terms. So we wanted to start with a very clear and concise definition of each. And when you hear AI, what does it mean? AI is basically a very broad concept, which means that we want machines to be able to replicate what we already have as humans in terms of intelligence. And there is a whole field that is leveraging different techniques to try to replicate that human intelligence. And that's what we mean by AI. And then there are some subsets of AI. The first one, and is what you'll see the most, is what is called machine learning. And machine learning, it's typically uses large sets of data. So you feed a lot of data into some type of models, and those models then can replicate how humans learn. And we're going to touch on how some of these things try to do that. We're not going to get too technical, but basically this uses very sophisticated calculus and statistics to replicate that learning. There are some others besides machine learning. One that you won't hear often from, but it's typically used as well, is something called alpha beta pruning, for example, that it's tries to perform a function without necessarily having to take a lot of data as input. That's not machine learning. That's another subset of AI, but machine learning it takes a lot of data as input to perform an output based on what it learned. And then there's deep learning. That's a subset of machine learning. And this goes even further into try to replicate how humans learn. And this is loosely based on how the human brain works, in which the human brain, typically the neurons interconnect through synapses, as you may know. And basically the deep learning, the neural networks do a similar function in that they have many different layers that perform different things. And what are those things? For example, if I'm trying to identify some type of node in an X-ray image, for example, one layer might be tasked with identifying the shape of that specific node in that image. And another layer might be tasked with identifying what's the circumference, for example, how large is it in that specific image. And another one may be tasked with identifying the different shades of gray. And that way it kind of replicates loosely, is loosely based on how the human brain works with those interfacing the neurons. Again, AI is the broad field that tries to replicate human intelligence. Machine learning is taking a lot of data input, and try to, through usually a labeling system, trying to replicate and get to the same conclusion that a human got to. And then deep learning is a subset of machine learning that it's using many layers to get to a similar output. And we have NLP, which is a branch of AI that also focuses on how humans talk. Because we don't usually speak in a structured manner like computers are usually process data. And you see those databases that have dates are one column, amounts maybe another column, names might be another column. We don't talk like that. We talk loosely, and it's very what we call natural, and that's what it does. The natural language processing. It's taking that human language and try to interpret what we meant and try to translate as well into a more structured way. So we just wanted to briefly start with those concepts so that those are clear, and in future conversations, you can have a more informed discussion around those. I'll pass it on to Rafa, who is going to explain how many of those terms translate into applications, specifically in healthcare. So Rafa, feel free to take it away.
All right, well, let's start by echoing what Edison just alluded to about AI being a broad term that encompasses other fields such as machine learning, deep learning, NLP. Okay, so we're good till there. That being said, let's dig deeper into ways that these technologies can be applied to enhance appointment scheduling at your organization, because I know that's what we're here for. And let's start by talking about scheduling process automation, for example, with tools such as conversational AIs or RPA, which stands for robotic process automation. So these resources can help you streamline and automate your scheduling workflows, no matter how they look or how lengthy they are, reducing human intervention and allowing you to scale your operations. Not to mention the positive impact in patient experience by understanding patient preferences and behavioral patterns. These things are very important keywords here because these are some of the benefits of implementing some AI algorithms, and we might not even be considering them in the first place. So another interesting application would be NLP, as Edison just referred to, and how it can be leveraged to enhance and automate patient requests using tools such as chatbots or self-serving platforms. This ultimately leads to actually the following application, which is action suggestions with different techniques. However, there are some particular ones that we like to use and we would like to expand on. For example, probabilistic next best action, which is widely used for marketers in several industries such as insurance, telcos, banks, to identify customer patterns that, together with real-time interactions, can be a powerful way to create hyper-relevant customer experiences. All these terms can be extrapolated to healthcare and implemented to our patients. Then we can maybe discuss a little bit about AI algorithms to optimize your resource planning. And we've heard a lot of you talking about resource planning and resource optimization, which is another gem that many healthcare centers are starting to adopt recently. These techniques consist of analyzing historical usage patterns, predicting demand spikes, for example, and automatically scale resources up or down according to your needs, your particular needs. And this on-demand scalability ensures applications run smoothly during peak times, for example, without over provisioning during low periods. Because as we all know, this industry, radiology, our industry, does require a lot of optimization and provisioning in order to optimize outcomes, and being a capital intensive business at the end of the day. Also, we would like to touch on, and of course, so after you have your patients mapped out and you understand their patterns and potential behavior, now it's time to automate communication between your clinic and your patients. This can be achieved by digitalizing your patient-facing processes and setting up rules to trigger those interactions. So rescheduling, cancellations, frequently asked questions are some of the things that can be automated and tailored to your patient needs and preferences. And last but not least, something important here is the machine learning and predictive analytics, which we have a whole section to go over this topic later on this presentation. However, this is one of the most important aspects of business applied data science, because the ability to predict customer behavior, in this case, patient behavior, and thus business outcomes, allow businesses to focus on what really moves the needle. So who to prioritize, which interactions lead to higher revenue, how to generate loyalty among your patients, thus increasing your customer lifecycle value, which is ultimately what we're all looking for. So some of these applications will have significant impact, on your top and bottom lines as soon as days before implementation. So maybe I think we could take some time now to answer some of your questions in case you have some at this point before moving forward. If not, then I'll pass it on to Edison now to delve into one of these applications that we just referred to, which is related to natural language processing.
Thank you, Rafa. And one of the key goals with this webinar from RBMA is that you get a sense on what are practical insights that you can take and implement as soon as starting next week within your center, within your radiology group. And we wanted to give you 2 specific examples on how you can apply this to drive value for your centers. The first one that we want to bring to your attention is how you can use NLP, which, if you remember, it's just understanding natural human language to do some things and help in your scheduling implementation. And why this is required is because we've all seen how the referring physician orders, especially for a outpatient radiology, but also even for inpatient, how those incoming orders are written by doctors, typically using non-structured language. And that non-structured language needs to be interpreted to make sure that we can get a very good result. And there are different techniques that we're not going to expand upon necessarily, just not to dig into too much technical detail. But there are some here that we mentioned in how you can implement these NLP-based models. Now, what does it do for you? It improves the operational workflows. It increases the effective resource allocation. And even more than that, it prevents revenue loss. And you might be asking how this can happen. Well, the first use case that we wanted to expand upon is probably you know this as radiology protocol. And that's basically understanding from both the medical history of the patient and also what is either the diagnosis or the symptoms from that patient, and then translating that into what specific protocol needs to be assigned to that exam that patient needs to go through. And we all know doctors are very well knowledgeable people, and they have to go through a very intense period of training and development and academic education to get to where they are. However, these are tools that can help doctors not rely solely on their education. And we that understand scheduling a lot understand that there are some things that these doctors might have missed, especially when we're talking about the referring physicians, just because it's not necessarily their day-to-day to understand, okay, I need this protocol on this abdomen MRI. So how we can help doctors understand the best protocol that we need to decide for this particular patient, and why do we need that? First is because there are some studies that tell that close to 6.3% of all the radiologist time are spent on protocol. And that's significant time that could be used, those are many hours, that could be used in interpreting images and providing results. The second one is because this is a significant source of denials. Once the payers understand that there's not a medical necessity for that particular study, if the protocol is wrong, then that might trigger a denial back from the payer. And last but not least, is because what we want to do is always provide, as care providers, we always want to decide the best treatment plan and the most appropriate and effective technique to care for the patient and provide that ideal care pathway. So we need to understand how we can help both the referring physicians, but also our scheduling team to select the appropriate exam so that it doesn't get later on to the front desk and later on to the technician, or even later on to the radiology, and help the radiology as well. One of the most significant use cases for this is help the radiology, because if you're doing the right protocol, then it's easier for the radiologist to identify any pattern when they are doing the reading. And how does it work? It's basically an NLP techniques that can take in all of the input from the diagnosis and then output, okay, this is the right protocol based on the historical of your exam and other exams at some other places. And why is this powerful? I'll give you two examples on how in practice this was able to avoid significant issues with two exams. One was an appointment that was received from a referring physician for a pregnant woman. And the order read, verify or confirm the heartbeat. As you all know, or as you may know, this is by default a stat. So an exam that needs to be performed with some urgency, as you know, and that could trigger even some legal implications. But typically, your scheduling team, if it's not well trained, they might have missed that because we're humans, we make mistakes, we might not be as well trained, we might have forgotten. With this type of tools, you avoid those situations because it can tell you that that specific order, which again is non-structural language, it's what the doctor prescribed and wrote on the prescription on the order, needs to be a stat and needs to have some type of a stat flag, thus preventing that the scheduler makes a mistake, which could trigger some, as I mentioned, significant implication. That's one example on how this could transform your scheduling errors and scheduling mistakes. And based on some of the research that we have done, we've seen that close to 4% of all the appointments are canceled due to scheduling mistakes for many different reasons, be it that you schedule a claustrophobic patient in a machine that couldn't host that patient, or some other issues with the wrong type of exam that was selected. So this could not only improve the outcomes for that patient, but also significantly reduce the potential missed revenue from appointment cancellations. Another one that I can mention is when a patient has a history, and this goes even to the medical history of the patient. As some of you know, and some centers do this, when a patient has a history of DVT or blood clots, typically that also triggers some type of stat flag. And what these type of tools can do is, based on that complete history of that patient, coupled with what are your specific protocols at your center, it can tell either the scheduler or even all the way up to the referring physician, if they have access to tools like this, that, okay, this needs to be scheduled as a stat based on that particular history for the patient. So, and how it does this, it basically takes a lot of different input variables, which includes, but it's not limited to, the history of diagnostics and labeling of all of these orders, typically hundreds of thousands of orders or even millions of orders, to understand, okay, this maps out to this particular CPT code and this particular protocol within your MRI machine or CT scan or even X-ray or mammogram. So again, this is a powerful solution that can be implemented in many different applications, specifically helpful in preventing scheduling error and also helping referring physicians understand and driving them through selecting the right protocol for the exam.
Yeah, definitely, Edison. But also circling back to something you mentioned at the beginning, imaging centers as well as other healthcare organizations have large amounts of textual, unstructured data stored within their systems. So this data is worthless by itself. It's just sitting there. So with proper data processing techniques, it can be leveraged to transform your processes and obtain significant efficiencies. I mean, further than because what we're sharing now, it's just one of the use cases that we've understood and seen through. However, there are significant efficiencies in the form of time reduction, better quality of output, as Edison very well mentioned, less scheduling errors, and overall better patient experience at the end of the day, which is, I know, what we're all looking for.
Great. So before we move on, I believe there are some questions from the audience. So I don't know, Megan, if you want to touch on those before moving on to the next section.
We had two come through in our Q&A. The first one was, what are some other use cases that work for radiology patient access?
Wonderful, wonderful. We've seen some implementations that are being used very powerfully across different radiology groups. One is and we're talking NLP specifically, it's the follow-ups. So understanding from the reading that result of that and that diagnosis from that exam that was performed, we need to understand what requires a follow-up and then schedule some type of follow-ups. That's one very powerful, because both it increases the quality of care for the patient, but also it addresses some legal requirements that some radiology groups may have in regards to the follow-ups after a reading came back with some type of result, any type of BIRAT or things that need to be that need to have some follow-up. Another one that it's very powerful and related to patient access, specifically the part of the prior authorization process, is the submission of the claims through some of the portals that require typically some type of questionnaire. Then we've seen how it can be implemented to using NLP, fill out those questions and answer some of these questions related to the clinical necessity by understanding what was that human language that was in the medical records, the medical history of the patients. So those are two very clear examples where NLP particularly is helping radiology groups perform better with their task and even avoid some legal implications.
Well, to expand on that one as well, Edison, another interesting use case comes to mind, and it's not necessarily NLP, however, it's machine learning related in regards to coding. So machine learning enabled coding, which is one product that we've been seeing taking off lately. And it's basically what it does, or what you can achieve through it, is decrease the rate of coding errors when you are billing, and this speaks to revenue cycle management specifically. However, it is we are under the understanding that this is also a pervasive issue for some imaging centers, and having machine learning predict what the right code is for each type of exam, having all these variables mapped in, variables already available from your wrist, it's also another way in which AI can help you streamline your processes and improve outcomes.
Definitely.
Awesome. We have a question in the chat from Clark. Do these tools include the OCR component?
Yeah, basically, this is not necessarily what we're discussing here. It's mostly a concept, not necessarily touching on any particular tool. So there are many tools in the market that can include how you translate the order if it comes through a fax, which is an image, and then you translate whatever came in into a text that can be inputted into your RIS or so many type of tool. But again, what we are discussing here, it's not particularly a tool, but the concept of translating whatever was in that order into the right exam to avoid scheduling errors and provide the appropriate care to the patient. You can find tools that mix both. Yep, that's possible. But we don't want to touch on any particular tool today. So.
And then one more in the Q&A. Sorry, guys. What are some more clinical applications of this type of AI in radiology?
That's a great question. What we've seen, and this is not necessarily NLP, but mostly the image classification. It's just understanding helping radiologists do their work and interpreting results. One particular one that we've seen, it's very powerful. It's everything related to what is called contouring. That basically it's a process that needs to happen before any type of oncological procedure after it was detected in an MRI or another type of scan that some type of cancer, for example. And that takes hours from the typically a radiologist in conjunction with the oncologist to perform that contouring. And what we've seen is that leveraging AI, that process can be reduced for 6 to 9 hours to 2-3 hours, a couple of hours, saving the medical personnel a bunch of time. The other that we've seen, it's just in helping the radiologists themselves, just identify better their images, even improving the quality of the images from older machines, older equipment that have been used, just so that he or she can read better whatever is in that image. So those are very powerful clinical applications of AI that have been developed and we know are in use by some radiology groups right now. Great.
Awesome, guys. That's all the questions we have at the moment.
Perfect.
Great.
So we can move on then to the next use case, and I'll pass it on to Rafa so that he can expand on what we refer to by patient no-shows.
Thank you, Edison. So when we're referring to patient no-shows, and I'm going to give you a little bit of context for this one, we've been working with local, regional, and national imaging centers for over 11 years at CCD Health. And I can assure you that patient no-shows is one of the most, both impactful and common issues found among radiology and healthcare groups within the United States. So what we did was when we first came in and we realized this was an important issue, we gather and structure our clients' data from the different sources such as EMRs, EHRs, and RIS, particularly in this case, to design a full-fledged AI solution to address this situation. So using machine learning algorithms, such as gradient boosting, random forest, support vector machines, sometimes even neural networks, which are very powerful, we have been able to create robust predictive models in the past, capable of telling who is more likely to not show up to their appointment, to their set appointment, with a high degree of precision. So that being said, I believe we can move on to the next slide. And something important here is that we use variables that are readily available. So we use data, large data sets that are readily available within your information systems already. So things like patient demographics, the day of the week, the time of the day, for the appointment, of course, patient previous behavior, zip code, the socioeconomical variables associated to the zip code are also very important. Insurance type, the amount of out-of-pocket expense that the patient will have to incur at the moment of the appointment, the modality the imaging modality, sorry, if it's a screening exam or if it's a diagnostic exam, the appointment lead time, among other things. We just wanted to mention a few of them. However, most of these variables used together have allowed us to do something powerful, which is build these models, these statistical models using machine learning that help us predict who is more likely to not show up to their appointment, and which are the main reasons. And we're going to expand a little bit on some of those factors and contributors later on another slide. However, you might be wondering here how it works or what can you do with something like this. And the magic is that you can segment your appointments and target your no-showers faster and more effectively. And these two terms are very important here, because as you can see on the right side of the slide, in just about 10% of your total appointment base, you can find nearly 40% of your total no-shows. So this is the type of things that really move the needle and increase what we call lift what we call lift in machine learning and data science, which is the capacity for you to identify groups or subgroups much better than in a random selection. So now comes the let's say the fun part, right? How can you impact no-shows having this information at hand? And I believe we can move on to the next slide, Edison. Awesome. So in here, first of all, it's important to mention that we have built models with over 90% precision, 70% 90% accuracy, overall accuracy, over 70% precision, and that can identify over 60% of your total no-shows, which is a metric that we call recall on the data science world. And quickly, not too technical, not too in-depth, but we wanted to quickly touch on some of these attributes and variables and how they impact the no-show probability. And this is a very used methodology, very widely used methodology called Shapley additive explanations. And what it basically does is that it explains the direction and the magnitude of the impact of each variables. And just quickly going through them, if we move on to the next slide, Edison, we can see some interesting nuggets that we have found out doing this type of exercise with different imaging centers across the country. For example, weather has tremendous predictive power over the decision of showing up to their appointment for different patient subgroups. For example, the distance to site, and it even might sound counterintuitive, but the further away you live from the site of the exam, the more likely you are to actually show up to your appointment. The appointment time, the day of the week, the age of the patient previous behavior are some of the most important determinants of no-shows. And if you identify each one of those determinants by themselves, you're probably not going to be able to do much with it. However, when you have a robust system such as this one that would enable you to get an overall probability score per appointment, then you will be able to take some actions based on these insights or based on these predictions. And moving on to next slide. So after you have identified who are those patients more likely to not show up to their appointments, which is the first step, and this is what you use the algorithm for, or any other technique that you would like to implement, there are several ways you can tackle that issue from your imaging center on an operational perspective. So for example, and this is one we like a lot, which is overbooking, such as the airline model, in which you identify those patients, those time slots, those times of the day where you have more patients with higher likelihood of not showing up to their appointments. And you take those time slots, you take those appointments, and you overbook them. And I mean, there are different things you can do here. You can just simply overbook them, or you can squeeze a couple of them by shrinking the duration of the exam. This has proven to be very effective, as there is always a small probability that both patients show up at the end of the day. So that way you mitigate risk, but also maximize your equipment utilization, because you're not going to have equipment idle sitting there waiting for nobody to show up at that moment. And that's the strategic scheduling, as we like to call it. However, there are other ways, because the first thing you might think about when you hear the term no-show is confirmations. So let's call everyone. Let's send SMSs to every person in our scheduling book. However, this is not cost efficient first, and then also this is not an effective method. It has been proven that response rates are low, and the real business impact is reduced with this type of massive approach. However, if you have that pre-cleaned, pre-segmented, and targeted population-based, appointment-based, as I already mentioned, then you're able to target them and maybe do an outbound program to have a phone call made to those patients and have an actual impact on their behavior. Maybe understand why they're not going to be able to show up. Maybe is time constraints. Maybe they run into some transportation issues. There are even centers, imaging centers, that are offering Uber transportation to their patients. However, this is something you can only do if you're able to properly predict who is more likely to not show up to their appointment, and being able to generate lift, which is the concept I was referring to earlier. So some of the benefits here for the patient is an enhanced confirmation method, and shortened appointment lead time. And then for the center, as I already mentioned, see, and now you're able to actually make it happen and recover that revenue. And here we have a little example, real quick example. These are completely made up numbers, however, based on the algorithms and some implementations we have seen. And this is an impact on your bottom line from a sample imaging center. Let's say this is an imaging center with 30,000 appointments a month. For your top 10% at risk patients is 3,000 patients. Let's say that you have 1,065 potential no-shows, and then you are able to prevent 533 of them, which is roughly 50% of your appointment at risk. Let's input, or let's say you have a fee schedule, an average fee schedule of $200, which leads to a yearly recovered revenue of 1.3, almost roughly $1.3 million. And a solution such as this one, considering implementation costs and staff, is around, well, it depends, but for an imaging center of this size is about $190,000, which yields an ROI of 5 times the investment, yearly, of course, realized yearly. So we just wanted to quickly bring this powerful, simple but powerful example, because we truly believe in the power of data, in the power of machine learning and AI overall, applied to the different business processes, not only on the clinical side, but also on the operational side, as we're talking now. And we have realized tremendous impact working with different imaging centers in the past throughout the whole country. So I don't know, Edison, if you wanted to add anything on this particular use case before moving on.
No, I think we can, before moving on, we can take a few questions if there are any from the audience. Or if not, we are ready to move on to the next section of the webinar, which is basically the closing thoughts. And what do we want for you to take home and potentially implement? Is that there are significantly and powerful applications that you can use from NLP, not only image classification, and again, not only in the clinical side, but also in terms of patient access, that you can start implementing as soon as right now and can yield significant results in terms of quality of care, but also the efficiency of your operations and how you minimize the missed revenue from either cancellations or no-shows due to scheduling errors or patient behaviors. And that can be accomplished through a combination of NLP and AI algorithms that can help you streamline those processes. Again, I would encourage our audience to keep exploring how well can they perform with the data that they already have. It's not necessarily complex. You can start pondering and understanding how is your data structure, what are the baby steps I can take starting now, and how optimized are my scheduling process? How streamlined is my scheduling workflow? So that you can understand, okay, I need to tweak it, I need better. Then is understanding the impact, right? How are scheduling errors, how is wrong exam selection impacting you or impacting your patients or impacting the radiologist that you work with, either be it a specific group, outsourced group that you work with, or any in-house radiologist for those that have them in-house. How is that impacting their time and their utilization? And how can I maximize the work that they do? That's one thing that you can start to measure. The other thing that you want to start measuring is the no-show rate. How well is your center doing in regards to no-shows? How much revenue are you missing out on? Is it a significant number? Should you take action on that? And then if the answer is yes to any of those questions, and if any of those numbers are impacting either your bottom line or the quality of care, then our recommendation is that you dig into, okay, it's AI the right tool to address those situations and those issues that are coming up because I'm reviewing those metrics. And then obviously after that is how you can modify your workflows to accommodate the use of AI. And it doesn't have to be a complete transformation. Usually, and the good thing about AI is that it can be accommodated to many different processes and workflows. So you can integrate it smoothly into whatever your workflow is right now. As you know, as long as it is within the ideal good practices in terms of appointment scheduling.
Definitely. And something, sorry to interrupt you there, Edison. Something interesting as well here is that by implementing NLP and AI, you're not only addressing or thinking about the present or addressing your current scheduling challenges, but you're also preparing your processes and your operations for the future. And this is very important because this is a wave that is coming. It's in most cases, it's already here as well. So we need to do whatever we can to ride that wave, because there are, as we already mentioned, significant, outcomes to get out of it. So I would encourage you to think about it as well.
Definitely. And again, the scope of this webinar was mostly related to scheduling, but there are so many use cases in patient access that you can also explore, like those that we mentioned related to prior authorizations, follow-ups and recommendations, and also the coding, automated coding, autonomous coding. That are applications of NLP that could be used to enhance your patient access process. And then obviously some of the ones we mentioned regarding the clinical side. So this is a wave that's coming. And our advice is that you better get on it as soon as now. With that, if there are no further questions, I think we'll leave you. We'll thank the audience for their attendance to this webinar. Hope that this was of use to you, and the insights that we shared can be applied to your centers. I think that was our main goal, that you can keep exploring and you can keep digging into how you can translate these into practical applications in your center. And with that, we thank you as well as the RVMA team. I don't know, Megan, if you want to close us out.
Yeah, guys, that was awesome and super practical. At RVMA, we really appreciate, just being able to take some things, from a quick webinar and being able to use it in your practice the next time. So I really appreciate, those great insights into AI. Thank you all for a great second session in our series. And don't miss our final session on deploying AI solutions in radiology at scale with Dr. Zaharchuk and Dr. Keller. We'll discuss enhancing imaging processes and scaling AI solutions effectively this Thursday, March 14th at 3 p.m. Eastern Time. Before you go, there will be a link to a survey at the end of this Zoom call. Your feedback is crucial for shaping future programs at RBMA. Thanks again, everyone, today, and we're looking forward to seeing you next time. Thanks, guys. Have a good one.